we have Shumo from Manta Network, who will be discussing on-chain privacy for Polkadot using zkSNARKs. Shumo.
Great. Thank you so much. It's my pleasure to speak at Sub0. So today I'm going to give you a technical overview and the vision of the Manta Network, the project we're actively building. First, just a little bit introduction about me. I'm the co-founder of Manta Network, also assistant professor at the UCSB. My little bit history regarding the blockchain. I ran the first blockchain seminar when I was a graduate student at the University of Washington. And I used to be a research scientist in Algorand. And I'm the builder of the PyTeal, Algorand smart contract language. And that's where I shamelessly claim this is my similarity to Gavin Wood, like we both wrote a smart contract language. So why I'm here today, right? So I think we all know, right? Blockchain is super cool. This is basically a blockchain transaction in Muggle's eyes, right? It's like Neo sending a payment to Trinity, and it's all crypto. It must be very private, right? So that's really blockchain transactions in Muggle's eyes. So in reality, right, what blockchain does is really like sending money over Twitter, right? You have this blockchain node, and you broadcast the transaction to all of the world, and it's stored. And what makes things worse is that this kind of financial information will store there permanently if we think blockchain will be there, right? So this is really, really bad in terms of privacy, and we have to fix that, right? So before we actually start to talking about any technical issues, this is actually before we even started the project last year, we actually did a survey, right? So our survey, we basically surveyed 404 users. It clearly shows privacy matters. So for example, like more than 80% of users have real concerns that there is linkage between their identities and the addresses, right? And once this link is leaked, it kind of leaked forever, and all their like financial history will be broadcast to the world forever. And secondly, more than 90% of users have inspect other people's wallet addresses, right? So raise your hand if you do so, have ever done so. And last, I think more than 70% of users have avoided or hesitated to make a transaction just because of the concern of privacy, right? You can view our privacy link study here in the link I showed the slides. So it's really a problem right now, right? So I will say, especially with more and more popularity of DeFi, right? So if we have a DeFi, but we cannot guarantee people's privacy, I will say this DeFi is missing a critical piece, right? So here's my claim, right? I think the future of DeFi is pre-fi, right? We want to give the user all their favorite DeFi product, but we also want to protect people's privacy. So that's exactly why we built Manta. So here is Manta's mission, right? Basically, we are a group of engineers and crypto experts. So we are the expert in privacy so that you don't have to be, right? So Manta's mission here is to provide on-chain privacy for all the Polkadot assets and even more, right? So let me dive deep into that a little bit. So for example, right? So where we want to be is that Manta wants to be the on-chain privacy solution that empowers the entire ecosystem, right? I think one of the great things about Polkadot is that it has so many amazing ecosystem projects, right? For example, just name a few here, right? For example, if Manta plus Akala, we can privatize the stable coins, right? So this is a cutting edge solutions privacy for stable coin product. And Manta plus Fala, right? We can leverage Fala's secure enclave solutions for online commerce, right? Build a fully private e-commerce platform. And last but also we can plus Shiden and privatize all the A-star assets. Last but not least, right? So we can collaborate with Moonbeam and to provide like a private ERC20 asset, right? I think Manta's position here is to be an ecosystem provider. So now let me dive into kind of what do we do? What are the exact product we're in the pipeline of launch, right? So the first product I'm going to talk about is Manta. We call it Manta 1.0, and it's a foundation layer. It's a MantaPay. So what is MantaPay, right? MantaPay is a decentralized private payment protocol, and we call it BYOT. Basically, it's like a bring your own token model, right? So technically works very similar to like a privacy payment protocol, like a zero cash. But here is a crucial difference. So we are actually one of the first multi-asset protocol that supports this bring your own token model. And here is how it works. So for example, let's say you have a public crypto tokens. It could be a relay chain asset, for example, Polkadot. It could be some Parity asset, for example, Akala or AUSD. It could be some like a wrapped tokens like wrapped BTC, right? So then you just call the mint function, right? We will transfer these public crypto tokens to private crypto tokens. We call it shielded tokens on Manta. And once they become shielded tokens, so these will be guarded by zkSNARK so that even us cannot see your information, right? And you could freely transfer the tokens to another shielded address on Manta. And if you ever want to claim your token back, you can use a reclaim feature, basically convert your shielded token or private token back to public token, right? So this is how MantaPay works. It's very easy to use. It supports multi-asset. Also, it hides both the transfer, the sender receiver, hides the asset ID. It also hides the transfer amount. So because this is a technical talk, let me dive into a little bit deeper. How does MantaPay work, right? So this is a very, very high level picture. First, in any kind of like a public blockchain, right? In very, very high level, you can think of how does blockchain work is that blockchain transit a database state or ledger state from one state to another. And how does it making sure this state transition is correct? Basically, spawn a bunch of validators to re-execute every single transactions. For example, if the transaction is Alice sent Bob 50 tokens, every single validators execute these transactions. And as long as they can agree with the result, then the block state moves on, right? So, and then this is how does Manta work. In very, very high level, right? Now the blockchain state, still blockchain state, but the blockchain state is encrypted, right? And now the transaction itself doesn't review what does the transaction do. So instead, it just kind of specify what is a transited state also encrypted will be, and providing a zero knowledge proof, which is pi here, right? And now what does the validator do is instead of re-execute every single transaction, it's using the zkSNARK validators to validating the zero knowledge proof. And by the property of zero knowledge proof, which you can infer from the word, right? It's zero knowledge. It leaks zero information whatsoever so that it can guarantee the privacy. You can see here in the entire process, nothing private information has ever been leaked, right? So now you might say, hey, this is really, really magic. How does this really work? Let me give you a very, very brief overview of how does zkSNARK works, right? So what is a zkSNARK? I think the way I interpret it is that zkSNARK is an encryption on computation rather than data. Let's say you have an arbitrary function, right? Fx equal to y. And the cool part here is that f can be any kind of bounded computation. In the academic jargon, it's in MP, right? So now, how do you may say, hey, like how do I encrypt this computation? What does that even mean? And here, this is concretely what does it mean, right? Let's say we brought out our two favorite figures, Alice and Bob, and Bob is a prover and Alice is a verifier. And Bob wants to prove to Alex the fact that Bob knows fx equal to y, but without telling Alice ever x and y, just purely the fact he knows fx equal to y. What does Bob do? Right? So they first do a phase called key generation. I won't dive into detail. Basically, it's generating some public parameters that both Bob and Alex can use. Next is that Bob run a prover program. So this prover program basically takes the public parameter, which is a PK. It takes the input X, takes the function. Oh, by the way, the function here is public, right? And it gives Alex three things: the encryption of X, the encryption of Y, and the zero-knowledge proof. And now Alex can use a verifier to check, basically takes the verification key and the zero-knowledge proof, can produce either yes or no. So the cryptographic construction making sure actually three things. First, Bob can never cheat Alex. And second, Pi needs zero information, right? And last, this entire scheme is sound, which means if fx equals y, Alex will return yes, right? So this is a super high level overview how the zkSNARK works. So here I would say zkSNARK is really the game changer for the entire blockchain space, actually for three major reasons, right? Privacy, that's obvious reason. And the second is actually efficiency, right? So zkSNARK is really efficient in terms of verifier type, right? And where the verifier is where the actually kind of the validator happens, where the gas cost is. And last but not least is composability. I mean, thanks for the recent development in zkSNARK, and zkSNARK becoming more and more composable, so that it for sure can enable general smart contract computation, right? So here is basically Manta's ZKP's concrete performance, right? So we are still using a zero-knowledge proof systems that require trusted setup. You can see we achieve amazing prover efficiency, which is only about 7 seconds in our prototype benchmark. Also, the verifier efficiency is very good, right? It only takes 10 milliseconds for the verifier to verify a single transactions. And of course, we put a lot of effort in our team to reduce the circuit size over these formats of ZKP design iterations. But the performance is actually really good right now, right? So that's about MantaPay, right? So the next step, well, I will showcase our second product, which is MantaSwap, right? I think this is one thing that currently missing in the space, right? We already kind of have sort of the privacy preserving cryptocurrencies like Zcash and Monero. But actually, if you look at the utility of the private cryptocurrencies, right, it actually nags the utilities here, right? So I think one of the bigger missing piece here is that people are not able to freely exchange these privacy tokens without getting back to the public tokens. So here, this is what we call Manta 2.0, which is MantaSwap, right? And from a higher level point of view, right, it works very similar to MantaPay. The only difference here is that now within Manta, you can not, in addition to send a private transfer, you can do a private exchange, right? You can exchange one version of the private token to another, right? So this is Manta 2.0 MantaSwap, and how we exactly do that? So we're leveraging a well-known decentralized exchange scheme called the automated market maker, right? So for the time's sake, I would not dive into the super detail in the automated market maker, but in the high-level idea here is that instead of trading with a counterparty, for example, you created such an order book, doing this order matching. Now, the idea here is that you are trading against a curve or trading against a pool, right? And this automated market maker will keep this AMM invariant. One of the simple invariant is X times Y equal to K. Basically, you are trading against this curve. And whenever a trade happens, you can think of the pool's position moving from the one point of the curve to another point of the curve, right? So, so I think you may see here, right? So what do we do, right? And also in a very high level, what we do is that we add this AMM invariant itself to the transactions and embed it in the transactions zero-knowledge proofs, so that you can freely exchange tokens using AMM privately on Manta, right? So we basically go through all this decentralized exchange schemes, and we find AMM is really the best for several reasons. The first reason that it provides a certain level of front-running resistance for the first. And secondly, it's amazing construction that saves gas, right? So this simple invariant is really gas efficient. And also at the same time, because it's a very algebraic invariant, so it's also ZKP efficiency, means that it would be able to construct a very efficient zero-knowledge proof circuit. And last but not least, it has a decent capital efficiency as well. So again, right? So MantaSwap works similar in very, very high level, works very similar to MantaPay. You can see the only difference here is that within the zero-knowledge proof, right, we add the AMM invariant here, right? So basically now instead of the zero-knowledge proof, now instead of showing, hey, like Alex sent five private tokens to Bob, it actually shows that, hey, Alex actually did this exchange with this AMM, and after the exchange in the new ledger state L2, this AMM invariant still hold. And of course, this is an oversimplification of the protocol, and we spend huge amount of effort to prove the privacy of the protocol. But this is in high level how those things happens here. So that's a MantaSwap. So MantaSwap is already finished the prototype, and we're working hard to making this prototype to the production. And now, last but not least, I want to show a little bit kind of a further overview of the final version of Manta, which is called Manta 3.0, which we want to become a privacy-preserving smart contract platform. So this is very similar to the story of Amazon, right? So, Amazon started a bookstore and become a cloud service. And we want to grow from a product and eventually to a platform, and for a good reason, right? So basically, right? So the Manta 3.0 vision is that after we have built MantaPay and MantaSwap, right? So these are the fundamental building blocks of our ecosystem. Then we're in a stage that we can provide the zero knowledge and also privacy preserving smart contract as a service to the end users. I mean, again, because we are the crypto expert, you don't have to be. You can just pick your favorite smart contract language to write a contract. It should be private by default, right? So this is the overall architecture. And of course, this is a little bit overview, right? So first we want to implement crypto ZK-friendly elliptic curves into the Polkadot runtime so that we have a better foundation to build all this, right? Then we want to abstract Manta out as a smart contract runtime and putting the two building blocks, MantaPay and MantaSwap, as a library so that your smart contract can call it. I think this is really important because this is really the two biggest usage of the tokens. Once you get a swap, once you get a payment, right, you can build a much higher level application on top of that. We'll also provide some a zero-knowledge proof gadgets so that you don't have to write everything from scratch. And then there are going to be plenty of application contracts to be developed. For example, ZK rollup, synthetic assets, insurance, and NFT, and so on. Right. So this is kind of our end version of the Manta and the final stage of evolution of Manta. So I think with that, so we basically have three concrete architecture goals here, right? Basically, we're in the Manta 3.0, we're moving from trusted setup to universal SNARKs. By the way, the jargon universal SNARK means that the SNARKs that doesn't require trusted setup. And next is that we want to go to semi-stateless. Also, we want to enable programmer-friendly ZK smart contract. All right. So with that, just show you a little bit about timeline. So we finished the design phase and we did the Web3 Foundation milestone delivery. And now our Canary network is already launched in Kusama and going to be launching all these product features soon. And we're very excited to join the Polkadot Parity auction. So with that, I will conclude here. So this is the incomplete picture of Manta teams. and we're also actively hiring. Yes, with that, I'm happy to take any further questions here.
Okay, yes, thank you very much, Shumo. We have a couple of questions. And the first is, you had mentioned how Manta can be used with other parachains. Can it also be used with parathreads or solo chains?
I think it definitely could. Basically, the Manta's mint function is going to be used called by XAM, right? For example, you have a parachain asset or parathread asset. As long as we have the XAM support, right? So basically, we can mint our tokens, right? So I think definitely could, yeah.
Okay. And this may be getting quite deep because I think it sort of is getting into the essence of zkSNARKs. But one user asked, how can a user create a proof of x times y equals k for the AMM if they don't know x and y?
And so that's very good question. X to Y is known. X to Y is the public information of the pool's position, right? So basically, the pool's position is still leaked. Also, it has to be leaked because you need to know the trading price, but your identity is sealed, right? So that's so we have to be precise here about the privacy guarantee we provide. Yeah.
Okay. Could you also provide private storage on Manta? So like data storage on Manta?
That would be absolutely technically doable. I think, but I think we need to deal with the blow up of the on-chain storage. So we need to think about how to better support that and what is, yeah, yeah, it's totally doable. And with zkSNARK, it will be actually having some cool applications. For example, you can have some zero-knowledge proof of your on-chain storage. Yeah.
Okay, interesting. And this sort of goes back to some of the things Gav had mentioned earlier in the keynote, that a major criticism of blockchain as a whole is its use in criminal activities. So how do you think that having a privacy on chain, how would you that fit into this narrative?
I think that's a very good question. So firstly, that we definitely, so first, I mean, there are like, this is a very long question. I hope I can give a simple answer, but these are the key points, right? So first is that I think privacy doesn't have to be conflict with like the regulation and prevent from the bad actors. But due to the permissionless nature of the blockchain world, it will be hard. I think it needs many kind of effort. For example, need regulation, the industry working together. But in the essence, right? So for example, we're going to provide the audit features, right? So basically, you can selectively provide to the law enforcement. Even actually, way cooler, you can provide zero-knowledge proofs of your auditable track record of the transactions to the regulations, right? So and also our protocol by design, it make audit easy. No matter it's a corporate audit, no matter it's an audit to IRS, to tax record, if you choose to, right, you can very easy to provide an auditable track record, even if it's hidden under zkSNARK. This is completely not conflicting with each other. But of course, there need to be more work on in this space to make it more to work both protect people's privacy and also against bad actors.
Okay, thank you. One last question that I see here. Could you compare Manta with zkSync?
I'm not sure I'm the 100% expert of zkSync, but I think a crucial difference here is that there are layer 2 solutions, and there are pros and cons of, I mean, we are a parachain, kind of like a layer 1.5, right? So there are definitely pros and cons in terms of that. But in general, I think we're in a very good position because we're a parachain, we can leverage all the wonderful infrastructure of the parachains to provide native support so that you don't have to worry about anything like decentralization, security of the asset, all these problems issued brought by the layer 2 approach, right? Also, I think even to the point, if our capacity become an issue, we can have our own layer 2s, so that we can having even greater capacity for our own, because we're essentially running a zkSNARK on chain. Yeah.
Okay. Well, Shumo, thank you very much. Really appreciate you taking the time to present and answer all the questions.